is Kamat, and today I'm going to share one video with you. This problem I have taken from the subject called hydrostatics. So before I begin to solve this problem, first of all I want to say something about this problem. So if we know the formula, then only this problem is very easy. So to know the formula, we know first of all we need to know the derivation. If we know the derivation, we know how to apply and where to apply this problem and this formula. So knowing that much is not enough. If we know the SI unit and if we know the formula, then only we can apply those formula in solving the problem. So knowing this much is sufficient to solve the problem. If we know this SI unit and the formula and the derivation on the basis of derivation and the formula and the SI unit, we can easily solve any problem. And most important thing is that we have to remember the formula. If we forget the formula, then we can't do the problem. So on the basis of the question asked in examination, we have to remember the formula. If we know the formula, then easily we can solve the problem. So let's begin. So one by one I am going to read the question, and after reading the question I will explain those determining the according to the question what the question is asking to solve the problem. Okay, so I am going to first of all read the question, and then according to the question I will find out what the question is saying. Okay, so I am going to find out. Okay, so let's begin. Okay, so this is the question. Okay, so question is here. Okay, question is saying to me, a single acting reciprocating pump running at 60 rpm delivers 0.53 meter per minute of water per minute. Okay, so the diameter of the piston is 200 mm and stroke length is 300 mm. See here, 300 mm, and then the suction and the delivery heads are 4 meter and 12 meter respectively. Then since this much value is given in this question, then the question is saying to me that determine the theoretical discharge, coefficient of the discharge, and then the percentage slip of the pump, and then finally question also saying that find out the power required to run the pump. Okay, so this problem is based on the hand pump. Okay, hand pump. This is basically used in village area. Okay, so how much pump is applied there, how many speed is applied there. Okay, in village area there is not a tap. Okay, there is no tap, only hand pump is there. Okay, so tap water is not there. So most of the villages areas people is using only hand pump. Okay, so using not only there is hand pump. Okay, so we have to use hand pump. Okay, if we are in village, then we have to hand pump. So relating to and that hand pump, this problem is based on. Okay, so okay, so first of all what I have to we have to find out theoretical discharge. To find out the theoretical discharge, we have to write down the given data. But given data is what? Given data is the speed here. Okay, as you can see here, speed n is equal to 60 rpm. 60 rpm is here speed. Okay, and then discharge QA is given is equal to 0.35. Discharge is also delivers 0.35 meter cube per minute. We have to convert it into meter cube per second. So if we convert, then it will become 8.83 into 10 power minus 3 meter cube per second. Okay, after knowing this value discharge. Okay, after knowing this discharge value, okay, we are we know the suction head value also. Suction head value is here. Suction head value according to the question. In question, suction head value, this is given data value only. Okay, suction head value is here. Suction head value. Okay, suction head value. Okay, so I am keeping here. Suction head value is also given 4 meter. 4 meter deliver head means suction head value. Okay, suction head is denoted by s. Okay, h suffix s. Okay, and then second value deliver head is h suffix d is equal to 12 meter. H suffix d is 12 meter. So deliver head is 12 meter. Okay, see here. Okay, deliver head is 12 meter is here. Okay, in question. Okay, and then total head. To calculate the total head, we need to add. We have to add these two values, suction head value and the delivery head value. After if we add these two value, 12 plus 4 is equal to how much? 16 meter. Then 4 meter plus 12 meter is equal to 16 meter. Okay, so total head is equal to total head h. Okay, h. The total head value also we know now. Okay, after knowing this value, what we are going to do? We are going to find out the diameter of the piston. Diameter of the piston is also given here. If you see here, diameter of the piston is given 200 millimeter is given. But if we convert in meter, then 0.2 meter it will become. Okay, and then stroke value is also given here. Stroke length is equal to how much? Stroke length is equal to 300 mm. So if I convert it into meter, then it becomes 0.3 meter. Okay, so stroke length is equal to 0.3 meter. Okay, so since I know the stroke length value, diameter of the piston value, d total head value, and delivery head value, h suffix d value, and the suction head value, then why can't I find out the theoretical discharge value? Okay, so theoretical discharge formula is 4 into L into N. Okay, for A into L into N. Okay, A is area into length, stroke length into N. Okay, since pi d square by 4. Okay, A, how we are going to find out the area? Pi d square by 4. So diameter of the piston, to find out the area, we use the diameter value, this 0.2 meter. Okay, 0. Pi d square by 4. So in the place of d, we substitute the 0.2 meter value, and we will square those value. Then by dividing it by 60, we will get the theoretical discharge value is equal to 9.42 into 10 power minus 3 meter cube per second. Okay, so we know the theoretical discharge value. Okay, so knowing this value, question is saying to me find out the second value. Second question is saying to find out the. Okay, if you see here, the question is saying to determine the coefficient of the discharge. Okay, means find out the, determine means find. Okay, find out. Okay, find out the coefficient of the discharge. Okay, coefficient of the discharge is equal to CD. CD is equal to QA. Means QA is what here? QA is nothing, it is a discharge. Okay, discharge by theoretical discharge. Okay, that original discharge by theoretical discharge. Okay, so theoretical discharge is how much? Discharge is 8.83 by into 10 power minus 3 by 9.9. How much we got? Theoretical discharge value we got, if you see here, 9.42 into 10 power minus 3 meter cube per second. Okay, so substituting this value, this 10 power minus 3 and 10 power minus 3, these two value will get cancelled. Okay, from denominator by numerator, both get cancelled. Okay, then getting this cancelling both this value, then using this value in calculator, numerator and denominator value, and calculating this numerator and denominator value, we got Coefficient of the discharge C suffix D value is equal to 0.93736. Okay, you can use this value and calculate it in calculator. Okay, so you can do it by your own. Okay, so now third thing is question is saying to me find out the percentage slip. Okay, percentage slip of the pump. Percentage slip of the pump formula is what? Percentage slip formula is theoretical discharge minus discharge by theoretical discharge. Okay, into 100. If I am doing then keeping those value in this formula, I am getting percentage slip is equal to 6.26%. Okay, I got this percentage slip percentage value also. After getting this value, I am going to find out the last value. Okay, that is what question is saying me to find out the power. Okay, power required to run the pump. Okay, means how much power is required. Okay, means how much we have to use the power to hand that hand pump. Okay, so power is applied there. Okay, in that hand pump. Okay, so power required to use that hand pump is equal to rho into G into theoretical discharge into H suffix S plus H suffix D by 1000 into okay by 1000. Okay, power is equal to now rho value will be constant 1000. Okay, and then G value is we know this is also constant value 9.8. Acceleration due to gravity value 9.81 into then theoretical discharge value we have 9.42 into 10 power minus 3. Then theoretical discharge plus head discharge, suction theoretical suction head plus delivery head. If we do then 4 meter plus 12 meter is equal to 4 meter plus 12 meter is equal to 16 meter. Okay, so this is total head. This suction head plus delivery head is equal to 16. So by dividing it by 1000 numerator and denominator both get cancelled. This numerator and denominator, this value 1000 and 1000 get cancelled from up and down. Okay, up is numerator and down is denominator. Okay, so getting both cancel and using this value in calculator, remaining value in calculator, how much we are getting, how much we can get. We can use this value in calculator and check whether it is coming same or not. Okay, so now I am going to check. Okay, because this is the final step. And okay, because you see this value and this value get cancelled. Okay, so what is left there? This value is one left. Okay, so 9.81 into 9.42 and 9.42 and this 9.42. Okay, 9.42 into 9.42 into 10 power minus 3. Okay, 10 power minus 3 into 16 into 16. Okay, if I am doing, then how much it is giving to me? See, same value is coming. It means I calculated the correct. Okay, my calculation is correct. Okay, so okay, my formula is also correct. It means my formula is also correct and my calculation is also correct. Okay, so in this way we can calculate okay the power of the suction head of the pump which is used in the single acting reciprocating pump. Okay, running in the delivery head and theoretical discharge and coefficient of the discharge. Okay, so this is the method, this is the process by which we can calculate the theoretical discharge, coefficient of the discharge, and slip percentage and power required to move the pump. Okay, power required to move the pump. Okay, so this is the method, this is the process by which we can find out the fourth thing. What is that? Fourth thing is, that is theoretical discharge, coefficient of the discharge, and slip percentage, and the power developed in the pump. Okay, so if you like my video, then please don't forget to like and subscribe to my channel. If we subscribe to my channel, then you will get a notification sign, so that you can watch me in next video also. Till then, tata, bye bye, and see you in next video. Okay.